Hello, this is Jeno Sheeba from Neet Gateway, part of Physics Department. We are happy to inform you that we are starting our Neet coaching in our institution to succeed your Neet examination. Let us move on to the session now. This is the previous year question paper split up for the 11th standard. 11th standard we are having 10 topics are there, and this is 12th standard topic wise previous year split up for past 6 years. Today we are going to see electronic device. In this topic I am going to take energy band in solids. See, we are going to see now today formation of energy band in solids. First, before that we are going to compare the materials. Materials are classified into 3 types. One is conductor, then semiconductor, and then third material as an insulator. What is meant by conductor? We know that in the conductor there are more number of free electrons are there. What is meant by free electrons? See, conductor means if an electron moves from one place to another place, the material becomes as a conducting material. So, if number of electrons are moving from one place to another place, the conductivity of the material takes place here. And here in the conductor there are large number of free electrons are available for the conduction. And semiconductor, what is meant by semiconductor? Here only few number of electrons are there for conductivity. And in the insulator very small amount of number of electrons are there in the material, because it is an insulator. Maybe some free electrons may be there or it may not be there. Free electrons may not be there in the insulator. Now the conductivity of the conductor is very high. We know that if there is many free electrons are there in a conducting material, the conductivity is high. The symbol for the conductivity is sigma. The symbol is sigma. It is approximately equal to 10 power 2 to 10 power 8 Siemens meter. Conductivity, the conductor material has the conductivity 10 power 2 to 10 power 8 Siemens meter. Now semiconductor, it is having, the conductivity is having 10 power 5 to 10 power minus 6 Siemens meter. And for the insulator the conductivity is very low. This is approximately equal to 10 power minus 11 to 10 power minus 19 Siemens meter. Okay. If in the conductor, I told you the conductivity is large because it is having many free electrons are there in the material. And if the conductivity is large means the resistivity must be low only. So the resistivity is low here, representing the resistivity symbol as rho. This is rho. And we know that conductivity is the reciprocal of the resistivity. Conductivity is the reciprocal of the resistivity. So resistivity, it is approximately equal to 10 power minus 2 to 10 power minus 8 ohm meter. Okay, ohm meter. And here in the semiconductor the resistivity is approximately 10 power minus 5 to 10 power 6 ohm meter. And for the insulator the resistivity is approximately equal to 10 power 11 to 10 power 19 ohm meter. Okay. Now we are going to see in the conductor has positive temperature coefficient of resistance. What is meant by positive temperature coefficient of resistance? See, when the temperature is increased for the conducting material, I am saying for a conducting material now, here the temperature, I am going to increase the temperature for the conducting material. So when the temperature is increased here, the conductivity of the material get decreased and the resistivity of the material get increased here. So the conductor may become as an semiconductor, or else it may become as an insulator when we increase the temperature. Okay, and in the semiconductor it is a negative temperature coefficient of resistance. What does mean by negative temperature coefficient of resistance? See, here I am going to increase the temperature for the semiconducting material now. So if I am increasing the temperature for the semiconducting material, what happens to the conductivity now? The conductivity get increased and the resistivity get here decreased. So the semiconductor material, it becomes as a conducting material when we increase the temperature. Okay, and here this is an insulator. Insulator, it may become as a conductor or it may not. When we want to give a very large amount of energy to the semiconductor, that is insulating material. Here also this is an insulator has negative temperature coefficient of resistance. Negative temperature coefficient. What does mean by negative temperature? It is same as that of the semiconductor. Temperature, I am going to increase the temperature for the insulating material. When the temperature is increased, the electrical conductivity get increased and the resistivity get here decreased here. So what is mean by resistance? Resistivity. So it restricts the electron flow. It cannot move from the electron, cannot move from one place to the another place. In the conductor I told you, if there is more number of free electrons are moving from one place to another place. So it becomes as a conducting material. Here only very small amount of electrons are there. So if there is very small amount of electrons, so if only very minute amount of current can takes place in the insulator. Okay. And some examples here for the conducting material, all the metals, it is a conducting material, aluminum, copper, etc. These are the example. And for the semiconducting material, silicon, germanium is an example for semiconducting material. We are using nowadays, we are using in the many devices, electronic devices, we are using semiconducting materials only. And in insulator, we know that insulator is a paper, then glass, plastic and all, it is an insulator only. Okay. Now moving on to the next one. Next slide. Now we are going to see formation of energy bands in solids. How the energy bands are formed in a solid material we are going to see. Before that, we want to know what is mean by atom. How the atom look like. Okay. How the atom look like? It consists of positive charge, that is nucleus. Inside the middle of the part in an atom, nucleus is present and electron is revolving around that. Okay, electron is revolving around that. We know nucleus, it is having proton as well as it is having neutron. Proton is positive charge and neutron is neutral. Neutral, what is meant by neutral? There is no charge. It is having no charge. So now say, what is the charge of the nucleus now? This is not having any charge. Neutron is not having any charge. So the charge of the nucleus is due to proton only. So it is positive charge. This is nucleus and it is positive charge. Okay. Now this is an electron. We know that electron is always, it is having negative charge. Proton, it is having positive charge, and electron, it is having negative charge. Okay. So the attractive force between the electron and nucleus is very much because it is having repulsive charges. Okay. And the electron is now tightly bounded to the nucleus. Electron is tightly bounded to the nucleus because it is having separate charges, positive as well as it is having negative charges. Okay. Now we are going to see, we are going to go inside the topic now. Formation of energy bands in solids. I am going to take, this is an atom, okay, this is an atom, this is an isolated atom. So an isolated atom, one atom consists of nucleus as well as electron is revolving around that. This electron, it is having the energy level as an E1. And we are going to see the energy level band for solid material. So this electron possesses only one atom here. I am taking only one atom. This electron possesses the energy level E1. Now I am going to take another atom here. This is another atom. It is kept apart, far apart. It is not close. It is not tightly bounded. It is far apart from each other. So this is nucleus. Inside we are having nucleus and electron. It is revolving around that. When two atoms are in the far distance, the energy level corresponding to this electron and the energy level corresponding to this electron will be same. Okay, the energy level corresponding to this one, this electron as well as this one will be same. I am saying this energy level also will be, it is E1 only. So it possesses one atom. When it is kept at an isolated atom, it possesses the energy level E1. When another atom is separated also, it possesses energy level E1. This electron possesses the energy level E1 also. Okay. Next part, now I am going to bring the two atoms closer. Okay. I am going to bring the two atoms closer. Now two atoms are overlapping. So when two atoms overlap each other, this is electron, this electron wave function corresponding to this electron wave function overlap with each other, and this energy level of an electron, it is now split up into two energy level, that is E1 as well as E2. Okay. Now this one, it is split up into E1 as well as E2. When the electron is, that is when an atom is brought closer together, that is this electron energy may not be same as that of this electron energy. When it is keep apart, two atoms apart, that electron energy will be same, and when it is brought together in an interacting system, but in an overlapping system, the energy of these two electrons will be differ. So it split up into two energy levels. It is E1 as well as E2 according to the Pauli's exclusion principle. What Pauli's exclusion principle says here? No two electron in a given interacting system. Now these two are in the interacting system, can have the same quantum state and hence the same energy. Okay. So if it is brought together, two atoms brought together, the energy level will not be same as that of this energy level, electron energy level. So that only the energy levels are split up into two, E1 as well as E2. Similarly, when three atoms are brought together, what happens now? Yes, now when three atoms are brought together, one energy level, this is an electron, this is an electron and this one is also electron. This energy level is split up into E1, E2, E3. So three atoms are brought together. So three energy levels we are getting, and when two atoms are combined in an interacting system, two energy levels we are getting. Okay. Now take a solid material. If you are taking, this is a solid material. If you are taking a solid material, we will have n number of atoms are there. So what is meant by n number of atoms? So n number of atoms is nothing but we are having millions of atoms in the solid material. So if there is a million of atom in the solid material, what we will get here? What is the energy level corresponding to this solid material now? Millions of energy levels will be there in the solid material, and spacing between the solid material will be very small. Okay, the spacing between the solid material will be very small, and this forms a band like structure. Millions of energy levels are there, n number of energy levels are there, and spacing is very small, so it forms a band like structure. It forms a band like structure. That is a formation of energy bands. Energy levels together it forms a band in a solid material. Okay. Now let's move on to the next one. Now we are going to see the classification of solids based on their band gap. Based on their band gap. Here we are seeing valence band as well as conduction band. For that we must know what is meant by valence band and what is meant by conduction band. See, we are going to see now what is meant by valence band and what is meant by conduction band. Now I am taking, this is one atom, that is a silicon atom. This silicon atom consists of 14 electrons are there. Silicon atom having 14 electrons. This is nucleus and first shell consists of here 2 electrons are there. It is K shell. This shell occupies 2 electrons. It is completely filled. This is K shell. And next cell, second shell, this is second one, it represents L shell. It is having 8 electrons are there. It is having 8 electrons. It is also completely filled only. Now the third shell, it is having 4 electrons. It is partially filled. 1, 2, 3, 4. Now if we count the electrons, we will get for an atom, silicon atom, we will get 14 electrons are there. Now our aim is to find what is meant by valence band and what is meant by conduction band. See what is meant by valence electron first we will see. The outermost, this is the outermost orbit which is occupied by an electron. Okay, outermost orbit occupied by an electron is known as valence electron. Outermost orbit occupied by an electron is known as valence electron. And the empty shell is known as conduction shell. Or else we can say that is a conduction band. Now there is a gap between this valence electron, valence shell as well as the conduction shell. So this gap is known as forbidden energy gap. This gap is known as forbidden energy gap. Now this is only one atom. Okay. If we are taking n number of atoms, if you are taking a solid material, so it is having n number of atoms are there in a solid material. So I am going to take now second atom here, silicon atom. Second silicon atom. This is the valence electron. This is valence electron. This is the third shell, valence electron. This is nucleus. Here we are having K shell. This is the L shell. And these third shell, valence shell combined with this shell. This is also valence shell only. Now it becomes now 2 atoms are close together. So how many energy levels will be splitted here? 2 energy levels will be splitted in this stage. Now I am bringing third electron means third energy, 3 energy levels will be there. So if I am bringing n number of valence shells are combined together, we are getting valence energy level, that is valence energy band. And these valence electron, outermost shell valence electrons are combined together and it is in the valence band. Okay, so this valence shell is completely filled in a solid material. In a solid material, valence band is completely filled, and the conduction band, this is the conduction band. There is no electrons are there in the conduction band. So the conduction band is empty. Conduction band is empty. Okay, now move on to the next one. Now we will see the classification of solid material based on their energy band gap. I told you what is meant by band gap. The gap between valence band as well as the conduction band, this gap is known as energy band gap. And for conducting material, conductor, the gap is 0, the energy, we are not having any forbidden energy gap. The valence band as well as the conduction band, it is overlap with each other. It overlap with each other for the conducting material. So if it overlap with each other, what happens now? The valence electron, here we are having many number of valence electrons are there in a solid material for conductor at T is equal to 0 Kelvin only. These electrons, there is no energy band gap. So these electrons are ready to go to the conduction band freely. When the electron goes to the conduction band, these valence electrons are tightly bounded. It cannot move to the one place to another place. when it goes to the conduction band, the electrons can move from one place to another place. So number of free electrons are moving to the conduction band and the material becomes as a conducting material. Okay, it becomes as a conducting material now. Now moving on to the semiconductor now. We know that what is meant by semiconductor? We know that it partially conduct current. Okay, it partially conduct current. At T is equal to 0 Kelvin, the valence band is completely filled by an electron and the conduction band is empty. And the conduction band is empty here. Now, the energy band gap is less than 3 electron volt. The energy band gap is here less than 3 electron volt. There is some energy band gap here. T is equal to 0 Kelvin. Now, if we want to become the material as a conducting material, what we want to do here? We want to increase the temperature. So, when we increase the temperature to the valence band, okay, we are increasing the temperature now. What happens now? The valence electron absorbs the energy and it is ready to go to the excited state. What is meant by excited state? Here the excited state is the conduction band. Okay. Now the electrons are moving to the conduction band. So what happens now? If an electron moves to the conduction band, it acts as a free electron and it becomes as a conducting material. Semiconducting material, it becomes as a conducting material. Okay. And third one is an insulator. We know that insulator means it do not conduct current. Insulator, it do not conduct current. So at T is equal to 0 Kelvin, always the valence band is completely filled by an electron, valence electrons, it will be completely filled and the conduction band is empty only. When we increase the temperature, if you need to bring, if you want to make insulator as a semiconducting material, we need to give more amount of energy, heat energy to the material, thermal energy. What is meant by thermal? Thermal is nothing but that is a heat energy. Okay, thermal is nothing but that is a heat energy. So if you are giving more amount of heat energy to this material, maybe this material becomes as a semiconducting material, but it cannot become as a conducting material because the energy band gap is very high. The energy band gap is greater than 3 electron volt. The energy band gap is greater than 3 electron volt. So these are the classification based on their band gap. Here in the conductor, the energy band gap is 0. We are not having any energy band gap. We are not having any gap. So the electrons are freely moving to the conduction band at T is equal to 0 Kelvin itself. The material acts as a conducting material. When we increase the temperature only, it becomes as a conducting material. This semiconducting material becomes as a conducting material. Hope you understood. Thank you.